Warm good morning to my dear students. So we will continue with the dynamics of particles. So today we are going to continue solving problems using equations of motion. So let me explain the problem. You have to determine the time required for a car to travel 1 kilometer along a road, and the conditions given for this is the car starts from rest and reaches a maximum speed of uh, at some intermediate point and then stops at the end of the road. So the acceleration of the car before it starts to deceleration is given as 1.5 meter per second square. Now the car starts from rest. So the below diagram explains here. The car starts from rest. Its acceleration is 1.5 meter per second square, and it covers 1 kilometer, that is 1000 meters. Intermediate to this, and finally comes to rest again at point B, and at its final velocity is 0. Intermediate to that, it reaches an acceleration of 1.5 meter per second square. So at this particular point, the brakes are applied and the car starts to decelerate. So this is about the problem. I will go to the solution part. So consider the motion of the car from O to A, that is up to the intermediate point. So the velocity velocity is 0, final velocity is maximum, acceleration is 1.5 meter per second square, and the time is taken as t1 and displacement is taken as s1. Now v is equal to u plus at, applying that v max is equal to, it starts from rest. So acceleration is 1.5 into t1, and t1 equal to v max by 1.5. Now again s is equal to ut plus half at square, and s1 equal to, again the initial velocity is 0. If you substitute s1 equal to 0.75 into v max by 1.5 the whole square. Now we will consider the motion of the car from A to B. Now here the initial velocity is the maximum velocity the car has reached, and final velocity is 0. Again here the car starts to decelerate, so it is minus 1.5. The time taken from A to B is taken as t2. Now displacement is nothing but the distance s2. Again, if you substituting, final velocity is 0, initial velocity is v max, and again acceleration is minus 1.5, we get t2. Similarly, s is equal to ut plus half at square, and we are substituting here v max into v max by 1.5. So we get the equation as s2 equal to 0.75 v max by 1.5 the whole square. And the total displacement is given by 1000, so which is s1 plus s2. And if you substitute the s1 and s2 values here, we get 1000 equal to v max square by 1.5, or v max is equal to 38.73 meter per second. So we have found the velocity. Now t is equal to v max by 1.5. So which is nothing but t is equal to 51.64 seconds. So the results we get is the maximum velocity attained by the car at the intermediate point is 38.73 meter per second. The total time taken for the travel for the car from O to B is 51.64 seconds. Another problem: a train is traveling with a speed of 90 km per hour. Slowdowns since a work is in progress at a retardation of 1.8 km per hour to 36.36 km per hour, while it travels 600 meters. So thereafter it gains further speed with 0.9 km per hour per second till it reaches the original speed. Find the delay cost. Now the data is given. So 90 km per hour. So 90 into to convert it into meter per second, 1000 by 3600, we get 25 meter per second, and acceleration is 0.5 meter per second square, and velocity v2 is 10 meter per second. Now acceleration a2 is equal to 0.9 into 5 by 18, so 0.25 meter per second square, and s2 is 600 meters. Now we are going to use the three equations of motion for solving this problem also. Now s2 is equal to 600 meters. Now we are using v is equal to u plus at for the first condition, and v2 is equal to u plus a1 into t1, and substituting the values we get T1 equal to 30 seconds. Similarly, V square equal to U square plus U2AS. I am substituting V is equal to 10 and U is equal to 25, and acceleration is deceleration is minus 0.5. If substitute, we get S1 equal to 52.5 meters. S1 is equal to. Now going to next step, S is equal to UT plus half AT square. From that already we know S2 is equal to 600 meters and V2 is 10. We get T2 is equal to 60 seconds. Now again the train is going to move with constant acceleration. So V is equal to U plus AT and U is 10 and acceleration is 0.25. We get the time T3 as 63 seconds. Finally, we are applying V square equal to U square plus 2AS and V is equal to 25, U is equal to 10 and acceleration is 0.25. So we get S3 equal to 1050 meters. Now, what is the total distance traveled by the train? So during the first displacement, it has covered 525 meters. During the second displacement, it has covered 600 meters. And during the third displacement, it has covered 1050 meters. So the total distance traveled by the train is 2175 meters. And total time taken again during the 525 meters it has taken 30 seconds, during 600 meters it has taken 60 seconds, and during 1050 meters again it has taken 60 seconds. The total time is 150 seconds. So if there is no speed, if there would have been no work speed, then V1 equal to 25, time taken will be 87 seconds. So the time delay is 150 minus 87, 63 seconds. So if there were no work between the train movement, and there would not be a delay of 63 seconds to cover the distance. Hope you understood this particular problem.